Hello, Algebra 2 small group. I am making this recording for you today for 7.07 margin of error because I am out doing the ACAP testing today. So I thought I'd make a quick video so you don't miss today's small group. So I am covering 7.07. I'm going to go ahead and get started. These are the announcements for the week. We're finishing up Unit 7. 7.08 was actually stretched over 3 days. We did the day 1 of Friday before spring break, and then day 2 and day 3 were Monday and Tuesday. Wednesday is 7.09 unit review for bonus points. 7.10 is the unit test part 1. And then we start a new unit on Friday, 8.01. The unit 8 is built into the OHS, so it's going to look a bit different. I will tell you that once you finish unit 7, the last 2 units that we're going to cover were designed to be easier units for you to finish out the year with. We know that you're tired, teachers are tired, so we did think of that, think of you, and think of us as we planned the end of the year. So if you can get through Unit 7, then 8 and 9 are going to be easier, I promise. At the top of this slide, I am going to remind you, if you're not the 10th or 11th grader, that you do have end of the year testing. That is virtual. Those are the STAR 360 tests. If you're 12th graders, you don't have to worry about that. And graduation is May the 16th. I had a little typo there. I had May the 18th. It is May the 16th. I'm going to get started with, I'm going to skip this since I'm recording. And we'll talk a little bit about margin of error. It says, take 2 minutes to think about what you think margin of error is. If we were in class today, I would have had you watch the video, but I'm just going to go ahead and talk a little bit about margin of error. So if we collected some data using a survey, and let's say there were 100 students in my class, and I wanted to find out what their favorite food was. And if I could send a survey out to all 100 of my students, and all 100 of my students could answer the survey, I would not need something called a margin of error. So we need a margin of error when we can't survey, or we cannot collect data from every single person in the population. So if I can only collect data from, let's say, 50 people out of my 100 students, then because I only was able to survey 50 people, then I would have a margin of error in my answers because I didn't get to select everybody. The more people you survey, the larger the amount, the smaller the margin of error. The less people you survey, the larger the margin of error, because we're not getting to select everybody. So if we wanted to ask our country a question, or to collect some data over all the people that are in our country, I think we looked it up. There's like 900 and something billion people. I think we looked that up in Monday's small group in our country. We definitely can't select everybody. So we have to have, when we select less than the number of population, we have to have something called a margin of error. So that's what 7.07, that's what our lesson is about today. So my first slide, I wanted to look at some abbreviations because, to be totally transparent and honest with y'all, I had also forgotten some of these abbreviations. They're only used mostly in statistics. And so we don't get to see these abbreviations over and over again. So if you don't use it, you lose it. So I had also forgotten. So I'm just going to kind of match these up for you. The little letter P without we call this a hat. So this second one is the letter P with an upside down V on the top. We call that a hat in statistics. So number 1 is just the P. Number 2 is a P with a little upside down V or a hat on the top. The little p stands for population proportion. The P with a hat on it stands for sample proportion. So just like we were talking about earlier, if I had 100 students in my class, P would be 100. And the P with a hat symbol on the top, if I only was able to sample, let's say, 75 of those students, then 75 would be my sample proportion. Number 3 is my mu symbol, my mu or my mu symbol. It stands for mean. We studied about that in Unit 6, and it is going to match up with B, population mean. My X with a bar over it, it's also a mean, but it's the mean of my sample. So mu is the mean of the entire population, and then X bar, we call that X bar, it is the mean of just the sample that I'm selecting. And then the last one is our sigma. We've seen that before in Unit 6. That is our standard deviation. So we'll talk a little bit about what those symbols mean. All right, number 2 says, what is the interval when written in the form of lower limit to upper limit? So I like to kind of draw like a little branch out here. I go up to the upper limit with the top branch down to the lower limit, and this says 76 feet plus or minus 2.1 feet. So the 2.1 feet is what we call our margin of error. So if we don't get to select or survey everyone in the population, then we do have that margin of error. So to get the higher limit or the upper limit, we're going to do 76 plus 2.1. That's going to give us 78.1 feet. And then to get the lower limit, we're going to subtract 76 minus the 2.1. That's going to give us 73.9 feet. And then we're going to follow this format. So it says parentheses, lower limit. So 73.9 feet, comma, upper limit, 78.1 feet. And then that's the answer that they want there. So we didn't have to find our margin of error. They actually gave us the margin of error in the problem. We just had to use the margin of error to find the upper and the lower limit. So add to find the upper limit, subtract to find the lower limit. In our next example, we're going to look at point estimate and margin. And so just to give you an example of point estimate, I'm going to go back to number 2. So 76 is the point estimate in this problem. 76 would be the number that would be right in the middle. If I could go over here, 76 would be right in the middle between 78.1 and 73.9. That's what we call our point estimate. So in the next problem, and I've got point estimate defined in the yellow box. It says when a sample statistic is used to estimate the population, it is the midpoint or the middle of the interval. If we're trying to find the point estimate, we can add the high and the low, okay, or the, how did they use the terminology here? They use the upper limit and the lower limit. So we can add the upper limit and the lower limit and then divide by 2 to find the point estimate. And then when we're finding the margin of error, we're going to subtract the upper limit and the lower limit, and we're going to divide by 2, and then we're going to remember that the margin of error is always plus or minus. So let's take a look at number 3. A local poll indicates that between 42% and 50% of local residents visit the nature park at least twice a year. What is the point estimate? So here's my lower limit, and here's my upper limit. Lower is always smaller than upper. So to find my point estimate, I add these. It doesn't matter what order you're adding in. It does matter what order we subtract in, but we add these and we divide by 2. That's going to give me 92 divided by 2, which is going to give me 46. And this was a percent. These were percents. So this will be 40%, 46%. So that's my point estimate. That would be the middle between 42 and 50. My margin of error is going to be plus or minus. And here you're always going to do the upper. So you always want the bigger number first minus the lower because you don't want a negative margin of error. And then we're going to divide by 2. So that's going to give me plus or minus 8 divided by 2. And that's going to give us plus or minus 4. And again, we are dealing with percents because that's what they gave us. So my point estimate is 46%. My margin of error is plus or minus 4% because I have to do 46 plus 4 to get to my upper limit of 50. And then when I do 46 minus 4, I get to my lower limit of 42. Number 4 says a sample proportion of 0.18 is found. To determine the margin of error for this statistics, a simulation of 100 trials is run, each with a sample size of 50 and a point estimate of 0.118. The minimum sample proportion for the simulation is 0.28, and the maximum, so I'm going to underline that, they're giving me the minimum, that's the same as the lower limit. The maximum, that's the same as the upper limit. It says, what is the margin of error? So that's what they're asking me to find, of the population using the estimate of the, and this is really important, I've got this red arrow pointing to standard deviation. When the problem says standard deviation, you're not going to subtract and divide by 2. You're going to use a different formula. Okay, this formula is specifically when the problem says standard deviation. So you'll have to read real carefully here. So it says you're going to do plus or minus, and you're going to do your range, okay, divided by 6 times 2. So our range is our max, which is 0.40, minus our min, 0.28, divided by 6. I know we divided by 2 on the earlier problem, but that problem did not say standard deviation. And then we're going to multiply that times 2. So it's going to be plus or minus 0.40 minus 0.28 divided by 6 is going to give me 0.02 times 2 is going to give me a margin of error of plus or minus 0.04. So I actually subtracted these two numbers and then divided by 6. That got me the 0.02, and then I multiplied by 2. So this would be my point estimate. They're not using percents in this problem. They just gave us a min of 0.28 and a max of 0.40. So let's not add a percent to that answer. Let's take a look at number 5. From a survey, a reporter determined that the true estimate of the proportion of citizens who plan to sign a petition is between 68%, that's my lower limit, and 74%, that's my upper limit. This says, what is the surveyor's margin of error? So it does not say anything about standard deviation, so I use the more simple formula of plus or minus subtract and then divide. So remember, we always want the larger number first, so it's going to be upper limit minus lower limit divided by 2. So 74 minus 68 is going to give me 6. So plus or minus 6 divided by 2. So that's going to give me plus or minus 3. And they are using percents in this problem. So my margin of error would be plus or minus 3%. So again, I'm going to slide back so you can see number 4. Number 4 says standard deviation. And that's when you're going to have to do plus or minus, max minus min divided by 6 times 2. If they're asking for a margin of error and they do not use standard deviation, then you're just going to do the upper limit minus the lower limit divided by 2, plus or minus, and then you'll simplify it out from there. So read the problem carefully. Number 6 says the results of a survey indicate that the true proportion of households who recycle paper products is likely in the interval of 0.61 to 0.7. So this is my lower limit. This is my upper limit. The lower limit's always smaller than the upper limit. What is the point estimate? So that's the number right in the middle. So that's when we add, and it doesn't matter which one comes first when I'm adding. If I'm subtracting to find the margin of error, I always want the bigger number to come first, and then I divide by 2. So 0.61 plus 0.7 divided by 2, add this first, then divide by 2, and that gives me 0.655. That would be the number that's right in the middle between these two. All right. We don't use plus or minus when we're finding the point estimate. We only use that when we do margin of error. All right, number 7's got a whole lot of words. Let's see if we can get through it. Based on a poll of 500 citizens, a property development group claims that 54% of the population is in favor of the construction of a new hotel near the airport. An environmental group claims that this poll is not valid and that only 38% of the citizens favor the construction of the hotel. To determine whether the sample supports the population proportion of 0.54, a simulation of 100 trials is run, each with a sample size of 200 and a point estimate of 0.38. The min is 0.32. The max is 0.50. The margin of error of the population proportion is found using an estimate of the standard deviation. That tells us we're going to use this divided by 6 formula. What is the interval estimate of the true proportion? So what we're going to have to do first is we're going to, what is the interval? We're going to first find, which one am I doing? I'm on number 7. So what I did first is I found, you can do a couple different things first. So I found the margin of error first. So I'm using this formula. So it's going to be plus or minus max, which is 0.50, minus min, which is 0.32, divided by 6 times 2. So that's going to be plus or minus. You're going to do 0.50 minus 3.2. You're going to divide that by 6. And then when you get that answer, you're going to multiply by 2. That's going to give me plus or minus 0.06. So this is my margin of error. Step 2, we're going to answer the question. What is the interval? So I believe in this problem, they did give us, here they gave us, this is what the environmental group is saying that they did a survey to see if the people wanted this hotel, and they said 38%. So to find our interval, we're going to take that 38% and we're going to do plus or minus. And we do have to think about this. Let's convert this into a percent. So we're going to have to move the decimal 2 places to the right. So our margin of error is going to be plus or minus 6%. Should have done that. So to find my interval, my low and my high, I've got to take 38%, and I've got to add or subtract the margin of error. So that means I'm going to get a high and I'm going to get a low. So 38 plus 6 is going to give me 44. 38 minus 6 is going to give me 32. And they like for us to write this high and low in an interval. It even says here interval. So we do parentheses. The lower limit always comes first, comma, the upper limit, 44%. So this is the final answer. I'll do swirly lines around the final answer. But first, we had to find the margin of error. We did the divided by 6 formula because it said standard deviation in the problem. And then our second step, we had to take the 38%, which is what the environmental company was saying was their survey, and we had to add and subtract that 6%. All right, I think this is the last one. Number 8, it says a recent poll taken by the movie theater industry shows that 28% of the population attends a movie in a theater at least once a month. A sample of 300 people shows that only 12% of the people attend a movie in a theater at least once a month. To determine whether the sample supports population of 0.28, a simulation of 100 trials to run, each with a sample size of 200 and a point estimate of 0.12. The min was 0.10. The max was 0.28. What is the margin of error of this population proportion using half range? So it does not say standard deviation. It does say half range, but that's still the same formula where you take your high and you minus your low and you divide by 2. So that's what we're going to follow. That's the same formula because this does not say standard deviation. So our max or our high was 0.28 minus our low, 0.10. Remember, we always do high minus low so we don't get a negative number, divided by 2. So that's going to give me 0.18 divided by 2, which is going to get me 0.09. And then remember, this is all plus and minus. I sometimes forget that. It's going to be plus and minus 0.09. You might see it written like that. You could also see it written as a percent. Remember, move that decimal 2 places to the right, and that's going to be a margin of error of 9%. Either one of those, depending on how they word the question. All right, guys, I hope this was helpful. Again, this is 7.08. I will include the whiteboard. So as you watch this video, you could fill in on the whiteboard if you wanted to, or maybe just have the whiteboard as a reference since there are some formulas on it. Hope this helps. See you guys later.